Hello everyone, my name is Dr. Mohit Sharma and in this video we will talk about reinforcement learning. So basically we will see what is reinforcement learning, what are its components and how it is different from supervised or unsupervised learning. So let's go ahead. So reinforcement learning is a branch of machine learning which is focused on decision making. Now what is decision making? Let us suppose we have a maze in which there are several obstacles, right? And the agent is placed here initially. So the objective is to make the agent learn to reach its final goal, okay, without interacting with obstacles. Okay. So out of all the paths that it can take, which can lead to its interactions with several obstacles, it has to choose that path which leads it to its desired goal without interacting with the uh, obstacles. So how does the agent learn that which path it has to choose? So that it learns by rewards and penalties or punishments. So if it gets stuck with the obstacles, it will get negative rewards or punishments. Or if it does not stuck, it gets a smooth trajectory up to its goal. It will get some rewards. So the main goal is to choose those set of actions at each and every point which maximize the long-term reward of the agent. Okay, it means that it does not need to have lots of interactions with the obstacles. So it will give us a signal, like if the rewards are increasing over time, it will give us a signal that the agent is learning and it will not stucking with the obstacles, right? This will increase the probability of the agent to learn the strategy to find the optimal path to reach its final goal, right? But how does it work? So the agent in a particular state, okay, within an environment takes an action, right? This is, let's say, state S. It will take some action A and it will reach to its different state S prime, right? So state is what? State is a current situation in the environment. So this is your environment. This is your environment, right? And state is a current situation in that environment. And the agent takes an action due to some strategy that it has, or maybe randomly it will take some action to reach to another state S prime, right? And based on the action that it takes, like let's say it could take several actions in all of the directions, right? But it chooses to take this action A, which leads it to state S prime. Now, maybe this could be a good action or bad action. We don't know. I mean, if it get a positive reward after taking that action, it means it is a good action. If it is getting negative reward, it means it's a bad action. If it is not getting any reward, it means that it is not making any progress. It is just roaming around, or it may be not moving, or it may be uh, switching back and forth, right? So when the agent m- makes a transition to another state, S prime, then that S prime becomes its new state. So that will become as an input state to make its transition towards another state, maybe S double prime. Then it has to take another action based on what policy it has or what strategy it will take. After, let's say, after, let's say, transitioning about all the states, it reached to its goal. Okay. After reaching its goals, it will up- update its policy for the next trial, in which, based on the negative feedback it has, it will try to uh, eliminate those negative feedbacks and try to make new actions in which it gets the penalties, or it will try to stick with those actions in which it gets reward. Okay, like let's say here it is in S prime double prime, and it makes a transition to S triple prime, but it gets a penalty here. It means that in next iteration it will avoid this path. But let's say if it going from state S to S prime and it gets a reward, so it will try to make this action, try to make this transition, okay, in the next iteration. So using this approach, it learns with time, and then ultimately it will find the path which leads to its goal without getting any penalties. So there are several algorithms which handle this update or updation of the policy, like Q-learning, which is very popular, which mostly handles the uh, environment which is very less complex, not many states or not many actions it has. Okay, and there are some other algorithms like policy gradient algorithms, which deals with very complex environments, right? In which there are a lot of actions and lot of states. Okay, but how this is different from the standard supervised learning or unsupervised learning? So the standard supervised learning use the label dataset. Like we try to map the input features with the output labels, and we will see in our prediction how the input, given the input data set, how well it is predicting the output class label. Okay, whereas in unsupervised learning we uses unlabeled data set. Like we have a clusters or some patterns are there in the data set, and we, let's say, given a point, we try to match to which cluster it belongs. Okay, there is no class labels given in the unsupervised learning. Whereas in reinforcement learning, we also don't have any label data set, but the agent learns only from the feedback mechanism that it gets from the environment. So basically, it is a trial and error mechanism. Okay, so this is to this for this video, and in the upcoming video, we will see how we can implement the reinforcement learning or the standard Q learning technique in the Jupyter notebook. Thank you.